Right then, I'm going to show you a very basic introduction on how to use the Fisher 3D printers. The Fishers are the black plastic machines with the three arms coming down in a delta fashion, as opposed to the Mendel, the other machine that you'll see out in the corner, which is more of a skeletal, wiry machine. Anyway, first of all, you've got to know whether or not your part that you're going to print is suitable to print. There's a few basic rules to bear in mind. The most obvious one is overhangs. So if you can see this part here I've got, it's actually a bit of a challenge which face is going to be sat on the bed of the printer. I could do it that way round, I could do it that way round. I can't really do it that way round because it's not going to be flat on the bed, we've got a curve. In fact, that would ideally be the best surface to print off. If I were to get rid of that curve, I could possibly sand it down, although sanding the 3D printed parts can be a bit difficult. So I might have to make a compromise with this part, because if I put it this way round, we've got this issue here, which is a bridge. Now, generally they don't like printing plastic in mid-air. It's got nothing to sit on top of, so you've got to bear that in mind. Small bridges like these holes, they're fine. There's no real rule of thumb, but anything over a centimetre starts to get iffy. Really depends what it's adjoining. So this one is joining that wall there, so it might be able to hold on to the adjoining filament there if you're lucky. But it's something to bear in mind when you're designing the object. You don't want to have big overhangs on it, and you want to be able to think about a flat surface that it prints off. So we'll give this a go anyway. I'm not guaranteeing I'll get a great part on the underside of this, but I'm going to have to try and print it this way around. Obviously this little spigot part here is going to be quite an issue, otherwise I'd print it there. But again, we've still got a bridge here to worry about. So although it looks like quite a simple part, this is going to be a bit of a challenge. Anyway, to print in Solidworks, we go File, Save As, and we need to make sure it's saved as an STL there. You can see that one. So I'm going to save that. Already done so, and you'll notice it now saves this triangulated mesh made out of triangles. That part can no longer be edited in Solidworks, that file. But it is suitable for outputting on the CNC machines and the 3D printers. It's a common format that these rapid prototyping machines use. So save that. Then you need to go to this icon on your desktop, Slicer. If you double click on that, now depending on whether your machine has used Slicer before, you'll see here a preset, Fisher. You'll also see that the bed is round. So that's the bed of the machine. You'll place your model on top of that bed, and you can add numerous models onto the bed. They all get printed in one go. But some of these machines won't have anything there. It won't be loaded as a preset, and you'll see a square-shaped bed there. Or they might have just had the Mendel loaded, so you'll only get this as an option. If that's the case, you'll need to load in the preset. So to do that, if you go to Load Config Bundle here, you'll need to go to Student Share, CAD, Slicer Profiles, and choose Fisher there. It'll ask you to restart Slicer as well, although we won't need to because we've already got the Fisher. So make sure you've got the preset set, and the printer is Fisher there. You'll then need to add your STL. I'm going to just need to go to that one there, and it'll load it in. You can see at that point whether your scale's more or less right. You get the rough idea of the size of the bed of the printer there. It's actually slightly wider than that, but that's the printable area. So you can just check that you've got the scale right at that point. Now, from this instant, you'll notice if it prints like that, it probably will fail. There's nothing really to hold it onto. It'll just fall off the bed because there's no real contact with the bed there. There's a massive overhang there, so we're going to have to change it to this profile here that I said. Now you might find this is a bit of a trial and error trying to work out which direction to rotate it. I happen to know these red, green and blue axes are always the same. The red is the first axis, that's X. The green one is the second one, Y, and the third one is blue. Red, green, blue is the order, but most people say the colours, and X, Y, Z. So you can work it out. If we want to rotate on this axis, so that's going to be the X axis. So if you right click on the model, go to rotate around X axis, it's another bit of trial and error. It's either going to be 90 degrees round like that, or 270 degrees round like that. So I reckon it's going to be 270. We'll give it a go. If not, we'll try undo it and type 90. That's right. Now there's all sorts of other options you can do. If you just want to print that one part, we could just go straight to export G-code. You've got the option to increase the number of copies. If you made one model but you want to print it 4 times, you can increase copies here, or in this case decrease copies. Similarly, you can rotate it a little bit. You can move it around as well relative to the other one. You'll notice it will print straight from the center, so you can only really do that if you've got 2 parts. They can move relative to one another. You can scale it as well, and occasionally it's quite useful if you want to salvage an old print that hasn't quite worked possible. We can split and cut it. So to cut, if you go to this button here, we can slice it at a certain point on the Z axis. That's quite handy if you printed this much and it's failed and you don't want to print the whole thing again. You can just print the top bit and stick the 2 together. Bit of a bodge, but it could be quite handy for you. So, export G-code. By the way, just keep it at standard quality as well. The fine quality will be finer, but it'll take so much longer, and the difference in quality is not much. Remember where you save it. I've got a folder here to print. So we're going to go to Studio Light Bracket.g code file. So that's the type of standard printer machine code file. So it's a set of axes specific to the printer. A bit like the CNC router's G code file, but they're not compatible. So once that's done, we now need to go to a browser. Now either use Google Chrome or Mozilla Firefox. Don't use Explorer, it just doesn't seem to work with these machines. So I'm going to just load this one up. Now if you notice on the machines, you've got the name written on the side of them. In this case I'm going to be using Iceman. So what I'm going to type is Iceman / and it should find. So sometimes they don't load straight away. It depends on whether or not the machine has recently been recognised by the network. Occasionally it takes a long time for it to get recognised, and sometimes I recommend trying it from a different computer if that's the case, if you're in a hurry. If not, just crack on with something else and just give it a little while. So when it loads, you'll get this interface here. This is the control panel of the 3D printer, and it's got everything you need to be able to do all the functions. This main page here is the basic functions of the machine. The various tabs to which you've got different parts of the machine's functionality are down here. So the machine control here, you start off by homing the axis. So it's a kind of basic calibration, so the machine knows where the top and the bottom is. So if you go home all, you'll notice all the arms go up to the top, click, and then come back down again. And it should land within about 4 millimeters from the bed. So that calibrates the top end of the XYZ movement. The bed end is done with this thing here, and you've got to do this after homing the axis. So you click there. It takes a little while, but you'll notice the arms are going round 3 corners and then probing in the middle. So it's just pushing down gently until it makes a contact with the bed. When it's done that 4 times, you'll notice down at the bottom here, we've got this number here, 1.516. Now as a general rule, I recommend doing this twice. Generally you just want to do a calibration until that number gets to less than 1. Now it might be fluky the first time, it might be less than 1. That was quite a good number and it will probably print quite well. But just do it again, you'll find that number's much smaller this time, so it's the error margin. And this time we've got 0.187, so that's a nice small number to use. Up here we've got the heater control. Now you'll notice on the Mendel we've got 2 heater controls because it's got a heated bed and a heated probe. Current temperatures, room temperature. To melt PLA, by the way I forgot to mention as well, we always print in this type of material, PLA. You do also have ABS, which is a common print material, but it's pretty nasty, gives off a lot of carcinogens and it's not very good for the environment. So PLA is a plant-based, a cellulose-based plastic. So it's actually not bad for the environment compared to petrochemical plastic. It's got different print properties, one of which is the temperature. So you'll notice when, in general, this machine's set up to print in PLA. You've got a range of temperatures here. By default it says 210. I like to print at 220. It'll work at 210, but you might find 220 just lets the... it's less likely to block in the nozzle. So, we've got it calibrated, we need to load the file now. So if you click on this tab here, this is the printer's internal memory and all the previous prints that people have been doing in the case here. So we just need to upload the file that we've just created in Slicer. So click on that one, locate the file, so it's in this one, I should be Studio Light Bracket, and it'll upload it here. Now really that's all you need to do. Next thing you need to do is just print it. So find it in the list down here and press the print button. So it'll ask you to prompt you, see if you want to print it. Yep. Now you'll notice here the heater's now active. I've got manual control to turn this on and off. It'll be quite useful. But if you're just going straight forward to print something, it'll just automatically switch it on when necessary. You notice here as well this temperature graph with time. It's going to go up, and as soon as it hits around this level it will start printing. So just be around the printer when it first begins, because generally the first time it fails, I mean the most common time it fails is right at the beginning on the first layer. You'll either find the most 2 common forms of failure, if the filament isn't quite being gripped by the extruder that well and it's not coming through the nozzle, or the print doesn't stick down to the bed. Now generally the print not sticking down to the bed will happen on the first layer, so you'll notice it fail quite soon if it doesn't work. Otherwise, if the filament gets caught on the spool, that can be quite a major fail problem. So just keep an eye on the spool being nice and free. Sometimes the filament will get tangled on the spool and then it will fail your print when it won't be able to extrude. So it's always worth just keeping an eye out, although if it gets caught it fails very quickly, so there's not a lot you can do. And like I say, you can salvage your print just by slicing it on the slicer again if you want. Anyway, that's the very basic tutorial on how to 3D print. I'll leave you to watch the time lapse of it printing and follow up with this video. We'll have another video shortly about troubleshooting the 3D printer. Thank you very much.